Question 31. A line passes through the point capital P, 1, 2, and meets the axes at capital X, x, 0, and capital Y, 0, y, where x is greater than 1. Part A. Show that y equals 2x over x minus 1. The gradient of interval yx is equal to the gradient of interval px since ypx is a straight line. So using rise over run, the gradient of interval yx is equal to negative y over x, and the gradient of interval px is equal to negative 2 over x minus 1. Equating the two gradients, we get negative y over x is equal to negative 2 over x minus 1. Multiplying both sides of the equation by negative x to make y the subject, we get y is equal to 2x over x minus 1 as required. Part B. Find the minimum value of the area of triangle XOY. Applying the area of a triangle formula, that is, area equals half times the base times the height, the area A of triangle XOY is equal to half times OX times OY, where OX is equal to X and OY is equal to Y. But we need to express A in terms of X, not in terms of X and Y. And we found from part A that OY, or Y, is equal to 2X over X minus 1. So the area A is equal to half times X times 2X over X minus 1, which simplifies to 2X squared over 2 times X minus 1, which equals X squared over X minus 1. And we call this equation number 1. The next step is to differentiate A with respect to X. So we need to find dA dx by applying the quotient rule, since we have a quotient where the numerator and the denominator are both functions of X. So dA dx is equal to 2x times x minus 1 minus x squared over x minus 1 all squared. That is u dash v minus uv dash over v squared, which equals 2x squared minus 2x minus x squared over x minus 1 all squared, which simplifies to x squared minus 2x over x minus 1 all squared. Next, we solve for x, the formula dA dx equals 0 to find any stationary points. And the only way that this quotient could equal 0 is if the numerator equals 0. So letting x squared minus 2x equals 0 and solving for x, and factorising the left-hand side, we get x times x minus 2 equals 0, and x, representing a length, needs to be greater than 0. Hence, a stationary point exists at x equals 2. So we're going to use the table of gradients to test the nature of the stationary point. So we know that at x equals 2, the gradient f dash of x is equal to 0. To the left of 2, I'm going to test x equals 1.5. We get a gradient of negative 3. And to the right of 2, I'm going to test x equals 3. I get a gradient of 3 over 4. So we have a negative gradient, 0, positive gradient. Hence, the stationary point at x equals 2 is a local minimum. So from equation number 1, the area is equal to x squared over x minus 1, where x equals 2. So substituting 2 into this equation, we get A is equal to 2 squared divided by 2 minus 1 in brackets, which equals 4. Therefore, the minimum value of the area of triangle XOY is 4 square units.